All right. So this Fitbit question, the first one is like, how can these two rates be different? And it's because they're two different rates. Like one of them is the average over a long period of time, and one of them is her rate at that moment in time. And so, I don't know, I don't run, but I'm sure you don't maintain the same speed the whole time that you're running. So that's kind of what that's about, the two different types of rates in this problem. All right, and then I talked a little bit about number two. And so anytime you want to find a speed, an average speed, you would take the distance the person traveled divided by the amount of time that they traveled. And one thing I'm going to tell you quite a bit this year, it's kind of like YOLO, but it's YORO. So you only round once. So when you do something in the calculator, um, don't round in the middle of the problem. So when you get this decimal for 41 seconds, you use that number again, just do either bring it back up, which you can't really on this problem, or just put a whole bunch of threes at the end. So you want to be accurate to three decimal places. So if you round too soon in a problem, sometimes it alters your answer, and you want to make sure you're good to three decimal places. All right, and then it is miles per minute because you had miles in the numerator and minutes in the denominator. All right, and then number three, we have this graph that represents her distance. And the question is, how would you calculate her average speed? And that's just going to be the slope between where t is 0 and where t is 62. So back in Algebra 1, when you guys first learned about slope, I think your teacher probably told you it is finding the average rate of change. So it's still a slope. So whenever we're finding the average rate of change, you're still finding a slope. All right. And then she obviously was not running at a constant speed because the graph is not linear. And then I thought that she was running the fastest, probably at about 35 minutes. Um, it might be closer to 38. So I would say about right here. Her slope is the steepest. So if you sit somewhere between 35 and 38, that's fine. But that's where her distance is changing the fastest over the shortest period of time, which is maybe when she's running the fastest. And then I didn't hear you guys talking about six as much as I heard my last class talking about six. Some people were thinking it had something to do with the heart rate, like the Fitbit was calculating the heart rate to try and figure out the speed at any moment in time. But what the Fitbit does is it looks at the change in distance in a very short interval of time. Um, you can't say that interval of time is 0 because you can't divide by 0. But what you're saying is the change in time is approaching 0. Okay. So let me give you guys your note sheet. And we're going to talk about two types of rates to change. So just like on the Fitbit, the two types are average rate of change and then the rate of change at a point. And so that's just like at a certain moment in time, the rate of change. So we're going to talk about rate of change a lot this year. And so sometimes when I'm abbreviating rate of change, I'll call it ROC. And on the AP exam, if this is a free response question about rate of change and you write ROC, the person grading your paper is going to know that you're talking about rate of change. So it's perfectly acceptable to do it that way. Okay, And so the average rate of change over an interval is the same as finding the slope over that interval. So think back to when you were first learning about slope. What did you use to find the slope between 2 points? Do you guys remember?
Rise.
The rise over the run. Does anybody remember it any other way? That is the slope-intercept form, and that is something awesome to learn. But what we're doing right now is just figuring like how you find that slope. Find the m. Say it again.
Y over X.
So it's the change in y. Good. Over the change in x. So that triangle is delta, and you probably have seen it more in your science classes and your math classes. Anytime you see that, it's a Greek letter delta, it just means change. So how do you figure out how much y changes? Like, what do you do mathematically?
Take Y of 1 and subtract Y times another Y.
Yeah, subtract. So when you want to find how much something changes, you subtract. Now, probably the formula you learned was y2 minus y1 over x2 minus x1. Do you guys think it matters that which is x2 and which is x1 and y1 and y2? Do you think the order matters?
As long as they correspond.
Good, as long as you're consistent. So if you do this y minus this y, just make sure the coordinating x's are in the same place. Okay, now I'm going to write this in a different color because in pre-calculus, the notation that we're going to use is slightly more sophisticated than what you learned in Algebra 1, which obviously it should be. And so if the function's name is f, and we want to find the rate of change from the interval from a to b, what we're going to do is f of b minus f of a. So those give you the two y values. And then that's going to be divided by b minus a. Now you can still think of it as the same thing. You're still finding the rise over the run. You're still finding the change in y over the change in x. We're just going to notate it slightly different. Now I want you to know what you're finding graphically or geometrically also. And so whenever you're finding the average rate of change, what you're finding is the slope of the secant line. Now, I used to think that you learned about this in geometry, but now I'm not sure if you do because nobody seems to really remember it. So we're just going to draw just this little random graph. It doesn't have to be perfect. It doesn't have to be wobbly like mine either. Just happened. I have no idea why that just disappeared. I hope it comes back. Okay. All right. So on this x axis, we're going to say A is here, and let's say B is way over here. All right, I'm going to go up to where A would fall on my graph, and then same thing with B. What a secant line is the line between those 2 points. So that is a secant line. And anytime you're finding the average rate of change, you're finding the slope of that line. All right, and at some point, not necessarily today, we are going to interpret the average rate of change. And I'm just going to fill in these blanks like how you would word it, and we'll come back to it on another day. But if you want to interpret it, then you would say that on average, the whatever the y variable is, just kind of fill in the blank with the words from the problem, changes by, and then you would fill in the average rate of change there. And using units is super important. We are going to use units today. But for your units, it's going to be whatever the y unit is per whatever the x unit is. So that's why on the one we just did, you did miles per minute because the Y unit was miles, the X unit was minutes. All right, so that's average rate of change. Now the other type is going to be the rate of change at a point. Now I looked through the standards for Unit 1, and they always call it this way. In calculus, we call it something else. So I'm going to tell you what that is. I feel like on our tests, it's not going to be worded that way, but in case you hear me say it, I want you to know that the rate of change at a point is also known as the instantaneous, whoops, let me spell it right. The instantaneous, that's a U, rate of change. Now, I tried to go back on these notes, and anywhere where it said instantaneous rate of change, I tried to change it, and I did notice this morning I forgot one of them. So, anyway, but I'm going to try really hard just to always call this the rate of change at a point, which is like whenever she just looked down and saw how fast she was running at that moment. Right, it's still going to be a slope, but instead of the slope of the secant line, it's going to be the slope of the tangent line. All right, so I'm going to do another little graph over here. I've got a little less space. All right, so when we're doing the rate of change at a point, we only need 1 point. And a tangent line just scrapes the graph at that point. Kind of goes with the flow of the graph and just scrapes it at that point. Now, we are not going to be able to find the rate of change at a point until we learn calculus. So what we do in pre-calculus is just estimate it. So, and it's definitely a standard to estimate it. So to estimate it, we're going to find an average rate of change on a small interval around x equals a. Right, so we want to get as small of an interval as we can, and it needs to include that point that we're trying to find the rate of change at. Okay, so let's do some examples. So doing example 1 is really common thing that we actually do in calculus. So you guys are getting a big head start on calculus for sure. So for number 1, the temperature of a pot of tea is as it is cooling is given by the function h of t, and it's measured in degrees Celsius. Time, which is lowercase t, is measured in minutes. So A asks, how fast is the tea cooling on average over the 10-minute interval? And we're going to show our work and give our units. So the 10-minute interval is the interval from 0 minutes to 10 minutes. So someone in my last class got slightly confused about that. All right, now I'm going to use the notation that we wrote up here. I wrote it in kind of a dark blue. So if I want to find this average rate of change, I'm going to do h of 10 minus h of 0 over 10 minus 0. So if you're just filling into the formula, A is going to be 0 and B is going to be 10. So what is h of 0? I said it backwards. What's h of 10? Tell me that first. What's h of 10? 43. So you just get that from the table. All right, what about h of 0? 66. And I'm just going to go ahead and say 10 minus 0 is 10. Technically, on the AP exam, you can leave your answer like that. You don't necessarily have, if it's non-calculator, you don't have to do that subtraction just in case you don't want to just make some kind of weird mistake. As long as you put the units, I am going to go ahead and subtract it. So I know when I subtract that numerator, I'm going to get negative 23. So divided by 10 is going to be negative 2.3. And what are my units going to be? What did I subtract on the numerator? Celsius. It's going to be degrees Celsius per, and then in the denominator, I subtracted minutes. It's going to be minutes in the denominator. All right, so that's the average rate of change problem that you might see. And then the next one, it asks to estimate the rate at which the temperature is changing at 3.5. That is not something that we can actually find. We just have to estimate it. So we're going to do another average rate of change to estimate it. And we want to use times that are close to 3.5, the smallest intervals that we could use. So what do you guys think those are going to be? 2 to 5. So we'll do h of 5 minus h of 2 over 5 minus 2. All right, so then I would just fill those in. All right, and there's really no reason to give that as a decimal unless it's a calculator question and it asks you to. I would just leave it as either as 52 minus 60 or negative 8 degrees Celsius per minute. Now it asks to explain the method, so we took the t values closest to and including t equals 3.5 and found the average rate of change. And feel free to use abbreviations when you're doing explanations. So that's how you have to do it whenever you have numerical data or a table to give your data. Now the next example, we have algebraic representation of our function. And this is something like what you did learn in Algebra 2 for sure. So if we want to find the average rate of change of that function on that interval, we're just going to use our formula. We're going to think of -1 as A, and we're going to think of 4 as B. And so it's going to be f of 4 minus f of -1 over 4 minus -1. If you would rather write over 4 plus 1, that's awesome. That's what I would rather write also. Minus the negative feels icky to write it. Now we can definitely do this without a calculator. So if I'm going to plug in 4, I know I'm just going to multiply that by 3. I'm going to get 12. And then I'm going to add 4 to that. And so it's going to be the square root of 16, which I'm going to break down a little bit more in just a second. You guys plug in -1 for me, please. Plug in -1 for x, this number here. What would you get under the square root? 1. What is the square root of 16? All right, and the square root of 1? You guys know the square root of 1. Thank you. You're saying it so quiet. All right, so we're going to end up getting 3/5. And this one doesn't have units because it's not a conceptual problem. It's so you just leave it like that. It's the average rate of change of that function on that interval. Hopefully that seemed familiar. You definitely did that in Algebra 2. All right, and then for example 3, this might be something that you're asked where you cannot use a calculator to look at the graph. You kind of have to know what this graph looks like. So do you guys remember what a square root graph looks like? Anybody? It kind of looks like this. I'll draw it. The original, like the parent function square root, goes through 0, 0. How would this one be shifted? Which direction if I'm adding inside the radical? To the left or to the right? Okay, it's going to be to the left. We will definitely go over all of the transformations, just not today. All right, and so we want to know, this is where I forgot to take off instantaneous rate of change. So we want to know if the rate of change at 0 or at 4 is going to be, which is greater. We want to know which one of those is greater. So if I draw a little tangent line here at 0, we'll say 4 somewhere over here. Which one of those do you guys think is greater? At 0. You're looking to see which one is steeper. So we're going to say at x equals 0 because the square root graph gets flatter as x increases. All right, all good? Okay, let's look on the back. We have one more example to do. All right, so we have this graph of g, and it asks us to find the average rate of change of g on the interval from 0 to 2. Now, I'm not going to use the formula on this one. I'm just going to go from 0 to 2 by counting. So we have this point here, and we have this point here. And I'm just going to go ahead and draw my secant line. All right, so instead of using the formula, I'm just going to do the change in g of x over the change in x. So if I go from where x is 0 to where x is 2, how much did I rise? 4. And then how much did I run? 2. So as long as you're going in a positive direction, you're going to do positive versions of that number. So that average rate of change is just 2. So if you have the graph, you can just count to find the slope. All right, and then this last one, we're going to order these from least to greatest. We're not going to actually find any of them. We're just going to kind of describe them. So the first choice is the average rate of change on 0 to 3.5. So I would say 3.5 is about right here. Maybe not quite that high. It's okay. So I'm just going to draw a little secant line. So if you were going to describe that, would you say it's a positive or negative slope? Positive. Would you say it's steep or not very steep? Not steep. That's all I want you to do on this. All right, and then the rate of change at x equals 1. So x equals 1 is a maximum point, a relative maximum, I should say. So I drew a tangent line, a graph that just scrapes there that goes to that point. What is it going to look like? What kind of line is that going to be? If it just scrapes at that point. All right, that's going to be a little horizontal line. I need you to take your earbuds out, please. You take your earbuds out, thanks. All right, so what is the slope of a horizontal line? 0. All right, and then the average rate of change from 1 to 3. All right, so here's 1. Here's 3. All right, would you guys say that secant line is positive or negative slope? The negative, so the dark blue one. Would you say it's steep or not steep? Steep. It's steep. All right, one more. So the rate of change at x equals 0.5. So we're looking for a little tangent line. I'm going to say it's about right here. A little purple one. That's positive slope. All right, what about steep or not steep? Definitely steep. All right, so you guys take how we describe those and order them from least to greatest. 1 being the least and 4 being the greatest, please. All right, so what questions do you guys have about the 2 types of rate of change?